We'll continue section 3.2 here, looking at our third and last method of solving quadratic equations, the quadratic formula method, right? We first had factoring method, then completing the square method, and this will be our quadratic formula. The idea here is that if we can write our quadratic equation in standard form, and if we do enough algebra, we always can, essentially we just want to get 0 on one side of the equation, then by identifying the coefficients, a, b, and c, and plugging them into this quadratic formula, we're able to solve for x. Notice that in the formula, there's a plus or minus. That's how we actually end up getting the two answers that we've come to expect from quadratic equations. One comes from using the plus, and the other comes from using the minus. All right. In order to apply this process to solving a quadratic equation, we do have to have that standard form. So one side has to be equal to 0, and then the other side has to be in standard form. And at that point, we just substitute, simplify, and solve. So let's try a couple of examples. In A here, I'm going to notice that it's already in the standard form. It's already equal to 0, so I don't have to do anything about that. I'm going to identify my A as 3, the B is 4, and the C is -2. Let me just jot down the formula here real quick. All right, let's start to substitute. The opposite of b would be -4, plus or minus, and under the square root, I've got b squared, 4 squared, minus 4 times a, which is 3, times c, which is -2. Make sure that's all under the square root. And then the entire thing divided by 2 times the a value, which was 3. All right, everything's plugged in. At this point, we just have to do some simplifying. So I've got -4 plus or minus the square root of, let's see, under that radical, I have 16 minus a negative is going to make that plus. 12 times 2 is 24. Looks like I end up with 40 underneath my square root. And by the way, you're also more than welcome to plug that into a calculator to figure out the number under the square root. No big deal. All right, denominator is 6. Next thing I'd like to do is to break down my radical. So looking at that, I'd like a perfect square that goes evenly into 40. And I don't think I'm going to do any better than just 4. Right? If we think again about our list of perfect squares, after 4, I don't think any of those go evenly into 40. So I'm just going to think square root 4, square root 10. So I've got -4 plus or minus the square root of 4 is 2 times the square root of 10 divided by 6. All right, there's a couple of different ways that you can write this and kind of where to go from here. We're most of the way there. Usually, kind of somewhat informally, people leave this all put together unless there's an imaginary piece, which we'll see in a later example. But we can separate it out if we want to. Either way, I'm going to notice that all 3 of my coefficients, the -4, the 2, and the 6, are all divisible by 2. So I'd like to reduce this to lowest terms by dividing top and bottom by 2. Right, again, I'm dividing by a fraction that's equivalent to 1, so I'm not changing the value of anything. I'll get -2 plus or minus just 1 times the square root of 10. Notice I can't divide under the radical, just the coefficient. And the denominator, there's 3. As I said, most of the time when we write things out by hand, most people are probably going to leave the answer the 2 answers connected into one presentation, if you will. But remember that this really means 2 answers. -2 plus the square root of 10 divided by 3, and -2 minus the square root of 10. Divided by 3. Sometimes my math lab actually makes you write both or type both of them in separately. You'll have to read carefully to see if they allow the use of the plus or minus symbol or not. Sorry, I didn't have my Desmos popped up here, and I wanted to make sure I did that so I could just show you real quick. You can also put this information into some sort of a graphing calculator, including Desmos. If you want decimal approximations for your answer, you'll just type them in really just the way that they look. So I could have -2 plus, gotta get my square root here, the square root of 10 divided by 3. And there's the decimal approximation for that. And then I could also have -2 subtract the square root of 10. Oops, gotta get outside of that radical. There we go. Divided by 3. So I get 2 answers exact. And then I can also get those same 2 answers as decimal approximations, about 0.387 or -1.721. Generally speaking, for our purposes here, since we've kind of looked at this one with the calculator, I'll probably just go ahead and leave them in exact form from now on. But absolutely, if you need a decimal approximation, not difficult to get with either Desmos or just a regular old calculator as well. All right. So let's take a look at another example. In B, I have a quadratic equation that's not right now in standard form, not equal to 0, right? I could just subtract the 8 to get the 0, but I kind of prefer to work with positive leading coefficients, so I think I'm going to move everything to the left side instead. So I'm going to add the 2x squared, I'm going to subtract the 5x, and then I just still have that plus 8 where it was on the left-hand side, and now it's equal to 0. All right, so we've got A is rather positive 2, B is -5, and C is 8. All right, quadratic formula starts with the opposite of B, so positive 5, plus or minus the square root of B squared. It's -5 squared. By the way, parentheses, they're really important. I think we talked about this earlier, but if you're going to plug that into a calculator and you don't put those parentheses there, you will not get the correct answer. Negative sign gets squared along with the 5. And then -4 times A, which is 2, times C, which is 8. And then that's divided by 2A. All right, so let's see what we got. We got 5 plus or minus the square root of, and under the radical here, I have 25 minus 8 times 8 would be 64. So notice I'm going to get a negative value under the radical this time. -39. All divided by 4. All right, we definitely know what to do with a negative under the radical, right? We're going to kind of pull that out as an I, imaginary unit. And I don't believe that there's any other perfect square that would be able to be used to break apart that 39. I don't think any of those go evenly into 39, so I'm basically just kind of thinking square root -1, square root 39. So I've got 5 plus or minus the I times the square root of 39 over 4. All right, this time we do have to split it up. Remember last time I told you it was sort of optional? Because this is a complex number, it has a real part and an imaginary part, we always write the real part and the imaginary part separately. So I would not leave this all as one big fraction. I would write this as 5/4 plus or minus I times the square root of 39/4. A real part plus or minus an imaginary part. And again, I'm fine with leaving it just like that. Do watch, like in my math lab or something, they may make you write it out, type it out twice, once with a plus and once with a minus. I'd like to say just a word about decimal approximations here. You can't combine the real and imaginary parts. So if you wanted some form of decimal approximation, you'd have to do the real and imaginary parts separately. Now 5/4, that's 1.25. And then we can do plus or minus. And then I'd have to do the square root of 39 over 4. Let's see here. Square root 39 divided by 4. It's about 1.561. I. That would be acceptable. Oops, make sure you can see the I there. But don't try to combine the real and imaginary. Those are not combinable, right? You got to leave the real and imaginary separate. All right, I've got one more specifically quadratic formula problem. And again, as I look at this one, first thing I'm going to notice is it's not in standard form. So I'd have to distribute the 4x squared minus 16x. And then if it's okay with you guys, I'm going to go ahead and subtract the 11 as well in order to get that to equal 0, which I have to use my quadratic formula. So this time, oops, looks like I need a new pen. This time our A is 4, B is -16, and C is -11. All right, so X would equal opposite of B, so positive 16, plus or minus the square root of -16 squared, minus 4 times A, which is 4, times C, which is -11, divided by 2 times the A value, which is 4. All right, I do not believe that I can probably effectively just do a little sidebar and kind of do most of the arithmetic in my head this time. So I'm going to grab that Desmos calculator again. And I'm just going to put in what's under the radical. Again, being really careful to make sure I've got that -16 in parentheses. Subtract 4 times 4 times -11 is going to give me 432 under my square root. All right, 432. I'm very suspicious that I'm going to be able to break that down. So let's think about our perfect squares list here. And let's see, 432. I'm pretty sure 4 goes evenly, but I bet we can get a bigger number than that. I think probably at least 16. Ooh, yeah. Let's see, probably even bigger. I'm going to try, I don't think 25 does. I'm going to try 36. Yep, 36 works. Anything bigger? 49's not going to go. 64? No. All right, tell you what, I think there's a bigger number, but I don't think we're going to find it on our list here. So I'm going to go ahead and I'm going to do the 36 and 12, and we may have to break this one down twice. So let's do square root 36, square root 12, what I found right here in Desmos. Square root of 36 is 6, and then the square root of 12, I can break that down some more, right? I could write this as the square root of 4 times the square root of 3. So what I actually have is 6 times 2 square root 3, or in other words, 12 square root 3 there. So I'm going to go with 16 plus or minus, and after all was said and done, I finally got that broken down to 12 square root 3 divided by 8. All right. The last thing I want to do is say, can I simplify that any further? This one is not imaginary, right? Not complex number. It's just all real numbers here. So it is okay to keep it all as one big fraction. But I'm going to notice that these coefficients are all divisible by 4, right? So let's divide by 4 over 4. Again, I'm dividing by a fraction that's equivalent to 1, so I'm not changing the value of anything. So 16 divided by 4 is 4, plus or minus 3 square root 3 divided by 2. And that would be considered the simplified answer. By the way, don't be tempted. I know you look at that 4 and 2 and think, oh, I could just divide that. Unless you're dividing all 3 of these coefficients, you can't divide the 4 and the 2. Now you could if you split it up. If you wanted to, you could say 4 divided by 2 is 2, plus or minus 3 over 2 square root 3. That's okay, but it's not necessary. Again, unless it's an imaginary result, most people just leave this as one big fraction, and you're welcome to do that. All right, to wrap up this unit, I've got one problem that we're going to kind of use to review all 3 methods. One of the things that I'd like you to get used to doing when you look at a quadratic equation is to say, what would be the simplest way to solve this quadratic equation? You may or may not always guess the quickest one first, but if you do, it can really save you some time, right? So, as I look at this equation, what I'd like to do is show you we can actually solve this all 3 ways: factoring, square root method, and quadratic formula. Hopefully you're already sort of thinking, do I maybe already know how to do, or is one of those the most obvious one? If you're thinking that already, that's good. But let's go ahead, do it all 3 ways, and then we'll compare and contrast after we're done. So method 1, we're just going to go in order that we studied them. Factoring. If I want to solve this by factoring, I have to get it to equal 0. That means I'm going to have to multiply this out first. So that's going to give me x squared minus 5x minus 5x plus 25 equals 9. Or x squared minus 10x, and I'm just going to go ahead and subtract the 9 right now, plus 16 equals 0. There's 3 terms here, so I'm thinking this is going to be one of those sum product problems. And it is just a 1x squared, so that's at least a little bit helpful. I know it's got to start with x times x. Then I'm looking for a sum of negative 10 and a product of positive 16. So I'm thinking 2 and 8, if I use negatives on both of those, should work there. So x minus 2, x minus 8 equals 0. And if the product of those two factors is 0, then either the x minus 2 is 0 or the x minus 8 is 0, giving me as my first solution x equals 2, and as my second one, x equals 8. Right? So that's one method. Our second method was the square root method. Now, if you looked at this right away and thought, you know what, this one's set up perfectly for the square root method, I'm with you. If I was just picking one, this is the one I would have picked, because we've already got something that's squared equaling just a number. That's exactly what we want for the square root method. So let's go ahead and take the square root on both sides, making sure to remember to put in that plus or minus square root of 9. And the square root and the square, inverse operations, they get rid of each other. So I just have x minus 5 equals plus or minus 3. So x minus 5 equals 3, or x minus 5 equals negative 3. That gives me x equals 8, and that gives me x equals 2. So the same two answers, just a bit of a different method. To me, at least, this seems a bit shorter, a little bit more direct than this one, although it's not. This one isn't terrible, but that one's probably a little faster, right? All right, our third method, and it does say start from the original equation each time, so my third method is going to be our newest one, the quadratic formula. So once again, with the quadratic formula, I need standard form. So I would have had to have started out again by saying, let's multiply this out. I know we did this once, but I just kind of want to see the whole method all together. So I'd have gotten x squared minus 5x minus 5x plus 25 equals 9. Or x squared minus 10x. And again, we could have gone ahead and subtracted the 9 to get the 0 that we know we need. So plus 16 equals 0. All right, if we were using the quadratic formula method, at this stage of the game we would have said, really a is 1, b is negative 10, and c is 16. So x would be the opposite of b, positive 10, plus or minus the square root of negative 10 squared minus 4 times 1 times 16 over 2 times 1. All right, that's 10 plus or minus. This one might not be too bad. Negative 10 squared is 100. Subtract 4 times 16 is 64. So that's 36 under the radical over 2. And this time what's under our square root actually comes out perfectly, right? So I'd have 10 plus or minus 6. Square root of 36 is 6 over 2. And if I take 10 plus 6 over 2, I'd get 16 divided by 2, which is 8. And if I take 10 minus 6 over 2, 4 divided by 2 is 2. If you look back now at all three of our methods, right, I'm hoping what you're going to notice is in this case, the amount of work that I actually had to do with this last method, the quadratic formula method, was by a pretty significant amount the most work that I had to do for any of them. The main reason I bring this up is that I find that a lot of students kind of get married to this method and they just try to solve every single quadratic equation with a quadratic formula. But notice sometimes you're doing way more work than you would have needed to had you chosen one of the others. So my advice here is really take a look at each problem. If it's set up perfectly for a square root method, that's what I would do. If you end up getting standard form and you can factor, that's what I would do, right? I actually use the quadratic formula as my last resort, never as my first choice. So keep that in mind, and hopefully you'll save yourself some work with these. All right, that brings us to the end of section 3.2.